Hello, everyone. Good morning. To authors and invited guests, welcome to Technical Session 5A. Myself, Ishita Solyan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress in Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event was held yesterday and is being held today, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we'll have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us Dr. Monica Rathod. Ma'am Monica Rathod, currently associated with IIM as Associate Professor. She has over 15 years of MCA teaching experience. She's Research Supervisor at Rajasthan Technical University, Kota. Currently, 6 students are pursuing PhD in Computer Science under her supervision. More than 20 research papers have been published in reputed journals. We welcome you, ma'am. We'll be beginning with our paper presentations now. I'd like to invite our first presenter for the session, Ahmed, with the paper titled Bayesian Optimization-Based Hyperparameter-Tuned Neural Network Regression for Smart Home Energy Consumption Modeling Using Weather Information. You may start with your presentation, sir.
Can you hear me?
Yeah, we can hear you.
Good morning, everyone. Thank you for joining us today. I am excited to talk about Bayesian optimization-based hyperparameter to neural network regression for smart home energy consumption using weather information. Outlines for our talk are as follows. First, we will look into the smart home dataset. After that, we will model a linear regression and examine the results. Then we will apply artificial neural network in the same dataset. Finally, we'll apply a pairwise hyperparameter optimization and discuss the results. In our dataset, we have the data was collected with a time span of 1 minute for almost 1 year, 350 days, of house appliances, which include 11 different types of home appliances like microwave, fridge, and others. With the same time period, the dataset recorded 11 weather information measurement. In the same time span. At first, we separated the dataset into two different categories. First, the appliances. Second, the weather information. In this heat map, we see if there is any correlation between any of the variables. It is clear for us there is no correlation between all appliances. The same thing for the weather information, except in some cases, which is expected in some weather readings. They have some related correlation. However, in the big picture between the weather readings and the home appliances, in our case study, there is no good correlation. Now we will look in the time series to see different shapes, different frequencies, and different peaks for each of the appliances. We have a vary values. All these values were recorded in kilowatt. This time series for the weather variables are shown different pattern. However, we must note that there is different units are used for each of these variables. And they are vary in the value and the shape and the peaks, and even the frequency through the whole year. Our first model, we applied a linear regression for our first model. We applied a linear regression for model 1, which take the first 11 variables, the home appliances usage. In the second model, we used the weather information. The results were very different. We examined by taking the adjusted R square, and for the first model, it was 0.5, which is a good start. On the other hand, for the weather information, the adjusted R square was 0.002, which is very, very bad. The hyperparameters in this model were the learner and the lambda. Both of these models take the least square as the best result. At this stage, we exclude the weather information from any further study due of the no impact in the model. We continue examine the usage appliances information for the next model. In the next model, we apply artificial neural network models. In this stage, we have four different types of hyperparameters. We have layer size. We have four different types of activation function. And we have the regularization term, which is a scale number, and a negative number. And finally, we have the standardized, the predicted data, which can take two values, true or false. However, to examine this huge data set with all possible outcomes of the hyperparameters, that may take ages. So we tried to, at first, to fix the last three hyperparameters and change only the layer size. So we set the hyperparameters for activation function as Rolo, and for lambda, we set it equal 0, and for the standardized predicted data, we put false. Then manually we name our layers, and these are the results. There is an open mic, please. The result was much better, and we can see with 10 number of neurons in each layer, and for single layers, we have 0.6 for adjusted R square. And this is going gradually to have 50 neurons and triple layers. And we see that how much the time is different. Next,
Excuse me, sir.
Yes.
My apologies, but I'd like to remind you of the time limit.
Okay.
Yeah.
So next, we fix the layer size at with single layer and 10 nodes. Then we try to pairwise the other hyperparameters. Our best result is in the middle one, when we fix the lambda, and we pairwise the activation function and the standardized, and we got 0.8 as R square, and these are very good results. Finally, we in our study we improved the goodness of the result by 56%. We examined different types of hyperparameters. Next, we will apply the same technique with more data set, and we might use the other objective for the multiple objectives for the same data set. Thank you very much. That's it.
Okay,
Any questions?
Mr. Ahmed, I have few questions. Like from where you have taken your data set?
I use an open source data set from Kaggle.
From Kaggle.
Yeah.
Okay. So did you apply any pre-processing tasks to it? Did you apply data cleaning?
Yes.
Which tool you have used for your research?
MATLAB.
MATLAB. Okay. And how did you come up with that idea that the based classification would work in that particular research? Have you applied the other algorithms, like you have used linear regression? So
Uh,
have you made work on the other algorithms also? Like there are different kind of regressions analysis and different classification techniques also. So how did you come up with that idea that you should use Bayesian classification, Bayesian theorem?
I understand that the neural network and has it is very powerful in MATLAB and straightforward to be applied. So I saw
Okay.
many examples
Okay.
in it.
So
Then
that
apply.
is only a suggestion that next time whenever we are using any regression or classification algorithms, so there should be a little bit of comparative analysis of those algorithms also, so that we can like put our conclusion that that is why this is the reason that we have taken this particular algorithm for our research. So there would be some parameters. It is not so that if particular tool is like few packages are available, or the tool is helping in that way, so we will use that algorithm. The algorithm, every algorithm has some features, and maybe for your experiment, few algorithms can work better. Okay, sir. Thank you. Thank you so much.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next presenter. I'd like to invite presenter Atra with the paper titled Bridging Nanomachines Bidirectional Channel in Bio-Inspired System. If you're here, then you can start with your presentation.
Yes, thank you. I will. Does the
It is visible. Please go ahead.
okay, thank you. Good morning and good afternoon to everybody. Thank you for giving me this opportunity to participate in this conference. My name is Atra Juhijani. I'm a lecturer at Al Nahrain University in Baghdad, Iraq. My paper is about bridging nanomachines and making communication between nano devices where the channel is a bidirectional channel and inspired by a biological model. So in order to understand the paper, I will start by giving a background about the subject of nanomachines and nano networks. Then I will give an idea about the communication techniques that are used in nano networks. After that, I will describe the main objectives of the model and describe the model and give the verification results of the model using a PRISM model checker. And after that, I will talk about the future work. As a background, nano networks is related to nanotechnology. Nanotechnology is becoming a key area in science based on multidisciplinary collaboration among medicine, engineering, biology, computing, and different other different disciplines, providing new tools that help to provide new solutions for different applications. The basic functional unit in nanotechnology is a nanomachine. So a nanomachine has the ability to perform simple tasks like sensing, actuation, simple computation. But if we have number of nanomachines that are able to communicate and share information, they would be able to perform more complex tasks. And by communicating, these nanomachines would form a nano network. So a nano network is number of nanomachines that are communicating between each other to perform some task. the thing about nano networks is that it has its own communication techniques. So when we talk about communication techniques in nano networks, it does not mean that it's downscaled version of the conventional network. Actually, there are specific communication techniques and communication paradigms that are used and specified for nano networks. Some of them are nano electromagnetic communications, where they are using graphene to design the antenna that used to communicate between these nano machines. And the other ones is molecular communication. It's inspired by biological paradigm and how these cells in a human body communicate between each other. So one of these communication techniques or the molecular communication techniques or the bio-inspired communication techniques is calcium signaling. And it's the one that we are inspired by our model. So calcium signaling is a well-established biological mechanism used for communication between neighboring cells through direct access. It's within molecular communication, calcium signal serves as a means of communication between nanomachines, where information is represented as calcium ions to facilitate the communication from the sender nanomachine to the recipient nanomachine. So for to give an example, if we consider this as a number of cells or neighboring nodes, and if we consider there's a transmitter nanomachine or a transmitter, and there's a receiver, so we can use these cells or nodes as a channel that would transmit the information from the transmitter to the receiver. Here's the symbol representation of the calcium signaling communication. Another concept that we are applying in our model is Applean sandpile model. It is a mathematical model. The main idea is about we have various locations, each associated with a value symbolizing grain on sand pile slope. Over time, these locations accumulate sand grains and gradually forming a pile. When the pile grows, reaching a certain threshold, and that threshold is predefined value, the location collapse, and some of the sand grain move to the neighboring locations. The sandpile model has been inspired used in our model to represent the behavior of nodes within the channel, where the excess molecular concentration at node is evenly distributed among its neighboring node when it's surpassed a certain threshold. So, sorry, there's a problem with the, just a minute. So the main objective of our model is to explore a communication between two nanomachines, and there's a node between the a channel of. Let me explain it on the. And better. So we consider that we have two nanomachines, ST and SR, and there are a number of nodes between these nanomachines that are act as channel nodes that would transmit the information from ST to SR. Both ST and
Yes,
SR.
Athra,
Yes.
as we have time limitations, so you are advised to kindly move to your main research work.
Oh, okay. Okay. So So the model process involve dynamic transmission and reception mode. So each nanomachine can be a transmitter or a receiver, but according to its, we have a local timer clock that would make these nanomachines transmit from a mode from transmitting or receiving mode. Each nanomachine is synchronizing with its local clock, alternating between modes. And these nanomachines can receive molecules from the environment, so that there will not be that the system would lose any molecules. And there is a probabilistic error with the transmission or receiving the molecules. So we can consider the failure of the transmission and receiving of the molecules. As we said, the communication channel using it is inspired by calcium signaling in biology and utilize the sandpile model, where when it's reached to a certain threshold, these the excess molecules will distributed to its neighboring molecules. And the model operate in discrete time slot, and according to the local time clock of each nanomachines, it will handle the molecule concentration. We used a PRISM model checker to verify the success or fail of the receiving or sending molecular concentration. So the PRISM model checker is a mathematical model. So we represent the model mathematically according to the language that is used in PRISM. So, and here's the a symbol representation of the graphical user interface of PRISM model. So we represent the main properties that we want to verify in.
Athra, please conclude fast.
Okay, so here are the properties that we try to verify, the success of the sending and the success or fail of receiving. And here are the result. The verification of send and fail in sending molecules concentration from either of the nanomachines, whether it's ST or RT. And we experiment that in two the channel nodes consist of 2 nodes or 5 nodes. The rectangular represents the 2 nodes, and the circle represents 5 nodes. The splitted line represents the fail of sending, and the other line represents the success of sending. The same thing, but here for verification of receiving or fail or success. The probability of successful transmission is consistently surpassed the probability of failure, indicating the reliability and of the model. Also, because I mean, even when we changed the size of the channel, there wasn't that significant changes in the probability. Although we didn't make the number of nodes more than 5, maybe that would change the results. So here's this summary of the we represent a communication model, and we tried where it's a bidirectional channel, and we try to check whether within the success and the fail of sending and receiving molecules among these nanomachines. The future work we are working on multiple access communication channel where we have number of nanomachines and there are communication between these nanomachines. Sorry for the delay, and thank you.
Okay, nicely presented, Atha. Can
Thank
we
you.
have the next presenter?
Okay, thank you.
Sure, ma'am. We'll be proceeding with our next presenter. I'd like to invite our next presenter. Our MUB, ma'am, with their paper titled Code Connect Classroom, a coding education tool enabling collaborative learning, real-time feedback, and student engagement. You may start with the presentation.
Thank you. Can you see this screen?
Yeah, it is visible. Please go ahead.
Thank you. Good morning, everyone. I am RNU Ratnayaka from Sri Lanka Institute of Information Technology. Today, I am thrilled to share our journey with you as we explore the Code Connect Classroom, a coding education tool enabling collaborative learning, real-time feedback, and student engagement. Our exploration today will cover various aspects of collaborative coding education. As you can see in the slide, I am going to cover these aspects. First, I am going to talk about the background of the research. Our journey begins with a glance at the dynamic landscape of coding education. Over the years, there has been a rapid evolution in how coding is taught. When it comes to traditional solitary coding activities, students often engage in solitary coding sessions, working on their projects individually. It can lead to disconnection and a reduced enthusiasm among learners. And as our educational landscape evolves, there's a discernible shift towards collaborative and interactive learning methodologies. So we recognize the need of transformative solution, a solution that brings collaborative and interactivity to the forefront of coding education. Let's shift our gaze to the specific problems that cast shadows on coding education landscape. One of them are challenges in assessing students. In the absence of active engagement, educators find it challenging to gain meaningful insights into the strengths and weaknesses of each student. The lack of engagement, beyond being a challenge, creates a disconnected learning experience for students. This disconnection goes beyond the classroom, impacting knowledge and practical application of coding skills. Teacher feedback is also very important in learning. It's not only acknowledges correct solution, but more importantly, address misconceptions and skill gaps. Without this feedback loop, students may carry unresolved concerns and misconceptions forward in their learning journey. Let's introduce our solution for these problems. Code Connect
Yes, you are
Classroom.
requested to kindly move to the literature review part and your actual research part.
Okay. Now let's zoom in on Code Connect Classroom and understand how it compares and contrasts with existing tools in coding education, such as iPad, Codeboard, and CodeKeep. When it comes to focus areas, while Code Connect Classroom prioritizes collaborative learning, iPad addresses the challenges in communication within large and web environments. Codeboard emphasizes versatile programmer cooperation, and CodeKeep provides a repository of coding tasks for learners. When it comes to target audience, Code Connect Classroom aims to transform the coding education experience, targeting for educators and students seeking an immersive and dynamic coding environment. Other tools cater to diverse audience, includes professionals, professional developers, learners, and many more. Now let's go into methodology, transforming from theoretical landscape to the practical implementation. Let's dive into the methodology that underpins success of our collaborative coding platform. WebSocket integration is the fundamental technical framework of Code Connect Classroom. It creates and maintains a persistent connection between users, web browsers, and the web server, serving as the infrastructure for the real-time interactions. The bidirectional nature of WebSockets is not only allows the server to push real-time updates, but also enables the client-side tracking of cursor movements and facilitates the swift delivery of feedback, ensuring highly interactive learning environment. When it comes to room creation and identification, the implementation of UUID algorithm, specifically version 4 with its high degree of randomness, ensures the uniqueness of room IDs. The technical choice minimizes the probability of generating duplicate room IDs, maintaining the integrity of each collaborative learning environment. The validation ensures the room IDs provided by the students undergo through checks. This validation directs students accurately to their designated classroom and maintaining a secure onboarding process. When it comes to secure learning environments, ensuring secure and individualized learning spaces is a technical priority. This involves creating a unique and secure environment for each collaborative coding session. That means at each room. Moving on to the interactive code editor. The interactive code editor powered by ACE Editor. It is more than just a tool. It's a focal point of the Code Connect classroom. It supports a variety of coding languages, including JavaScript, Python, Java, and many more. The syntax highlighting implemented through the Dracula theme enhances productivity and understanding. In conjunction with the code editor, the dynamic sidebar, which displays connected users, provides language selection, adds depth to the user interface. Moving on to the real-time interaction, it is made possible through WebSocket events. As users enter or exit collaborative sessions, there are event triggers and displays of connected users, provide continuous cursor highlighting, and synchronize instant code and language updates across all the clients. Now let's move on to the results. We achieved a significant milestone with the successful development of Code Connect Classroom. The platform offers an online space that is not only user-friendly, but also robust in facilitating collaborative coding sessions. When it comes to tangible outcomes, the tangible outcomes of this development are evident in user-friendly interfaces and the integration of features such as real-time collaboration, syntax highlighting, and quick feedback. These aspects contribute to a more interactive and engaging coding experience. The results are fascinating, but let's delve into the discussion. One of the key aspects we need to discuss is the impact of WebSocket integration. This technology serves as the backbone of Code Connect Classroom, enabling seamless bidirectional communication. When it comes to real-time collaboration and feedback, they are not just features, they are catalysts for increased student participation and engagement. When students can immediately see code changes and track cursor movements they receive prompt feedback, it transforms the learning experience and make it more dynamic and interactive. In conclusion, the Code Connect Classroom emerges as a transformative tool in coding education, presenting a dynamic and engaging platform for both educators and students. By effectively addressing challenges such as low student engagement and limited interaction, it introduces a new paradigm in collaborative learning. The real-time collaboration and prompt feedback mechanisms embedded in the platform revolutionize the traditional coding education landscape. This innovation not only bridges the gap between teachers and students, but also enhances the overall learning experience. As we look forward to the future, Code Connect Classroom holds the potential to shape the way coding is taught, providing a foundation for further advancement in collaborative coding education. Looking forward, we have identified some areas that demand deeper exploration. One of them are understanding how different learner profiles interact with the platform, and then long-term assessments on coding proficiency, and the integration of additional features, which will be exciting and which will be existing possibilities for improvement. Before we wrap up, a moment to express gratitude. A special thanks extend to my four co-authors, Dr. Dilshanti Silva, Mr. Ejiketi Jayatilaka, Mr. S.M. Shapri, Mr. S. Vidanarachi, who have been instrumental in shaping and contributing to this research. And I also wanted to extend appreciation to our institution, Sri Lanka Institute of Information Technology, for providing the resources and support. And additionally, a heartfelt thanks to all contributors and supporters who supporting development and research journey of Code Connect Classroom. It's through this collective effort that we've been able to bring innovation to the forefront of coding education.
Yes.
Now let's open the floor to question and discussions.
Yes. Can you please highlight two areas wherein you can say that your particular software is better than existing available softwares?
We have in according to this literature review that we have wrote, the iPad is used in all the lab environment. That it is an online platform that there are different students from different locations can access the same classroom at the same time for their coding education purposes. They can see others cursor pointers and what others are doing with their code and how the code is working, and teachers also can guide through the code parts, and there's a feedback mechanism. It will helps to give feedbacks for the code part, and that's the difference between existing solutions and our new solution.
Okay. So did you apply any payment gateway also?
No, it's all free.
Okay. Yes, ma'am. Can we have the next presenter?
Thank you.
Sure, ma'am. We'll be proceeding with our next presenter. I'd like to invite our next presenter, who is TD Jayasinghe, with the paper titled Code Rookie, Educational Java Programming Environment for Beginners. You may start with your presentation, sir.
Hello, am I audible?
Yeah, you're audible.
Can
Please
you
go
see
ahead.
my screen as well?
Yeah. It is visible. Please go ahead.
Okay, good morning, ladies and gentlemen, and thank you for being with us here today. My name is Pasindra Jayasinghe, and I'm excited to present our research, Code Rookie, which is an educational Java programming environment for beginners. So, in this presentation, I'd like to give you an overview about Code Rookie, our user-friendly Java programming environment for beginners, and how it addresses the issues that are faced by noise programmers in the current landscape. Also, by your presentation, we'd like to give you insights on how Code Rookie, on the background and the issues that led to the development of Code Rookie, and the significant features of our platform, as well as how our platform performed in the real world when it was introduced into real noise programmers, and the feedback that we got from them. So, moving on to the background, in the rapidly evolving current technological landscape, there's an ever-growing demand for programming skills across various industries. As technology continues to advance day by day, there's a high demand for programmers with a good skill set in programming and as well as confidence, especially confidence when it comes to programming. And it is not limited just only for software development. It is a requirement that is felt in other industries as well. And unfortunately, noise programmers face significant challenges when starting their coding journey. So to get an idea about the challenges that are faced by them, we conducted a survey. The survey, a sample of 50 undergraduate students were considered as the sample in this survey. And in this survey, as you can see on the slide as well, 71.4% of the our sample survey students found that they had an unclear path to progress. That means they had no idea about what to do, what are the milestones that they should follow and to achieve in order to be a skilled programmer. Also, majority of them, 85% of them found that limited collaboration was a major concern that they had when it comes to programming. Also, lack of clarity in visual programming as well as lack of immediate feedback were found to be major concerns that they had. And finally, confusion due to error messages was also a major concern that they experienced when it came to entering into the programming area. So, taking these facts into consideration as well, we summed it up to some key points. And not only that, natural development environments as well as integrated development environments proved to have somewhat complex interfaces and error messages, which proved to be a bit of a challenge for noise programmers to grasp and understand those error messages precisely. Due to that, most programmers felt stressed and they didn't want to continue further into programming. Also, error resolution challenges were experienced by noise programmers. They experienced complex error messages and they couldn't resolve those error messages by themselves. What they needed was simpler error messages that they could easily grasp and understand and find the solutions to. Also, limited interactive learning. That means that they were solitary when they were learning in current programming platforms, and they had no peers to track or to relate to and to get an idea about where they stand when compared to other peers around them. Also, the absence of feedback was a major concern that were experienced by noise programmers. Feedback is crucial for us to get an understanding about where we stand, and through constructive feedback only we can improve ourselves and to identify our weaknesses and to convert those weaknesses into our strengths. Also, this scarcity of practical experience. That means noise programmers didn't have a way to apply the theoretical knowledge that they had in their head into the real world scenario. That was also a major concern that was faced by noise programmers. So, in order to give a solution to all those issues and the challenges that were faced by noise programmers, we came up with CodeRookie. CodeRookie is a user-friendly Java learning platform that is targeted to improve the efficiency and the confidence of programmers when it comes to learning about coding. So, to develop CodeRookie, we use MongoDB, Express, React.js, and Node.js framework, also which is known as MERN-Stack. We use MERN-Stack to develop our platform. And when it comes to identifying the key features of CodeRookie, the Java theory learning point, the Java compiler, saved compiled code history can be introduced as significant features as well as community support. The unique feature that we have in our platform is the AI-driven error feedback tool. So moving on, as a first feature, we have the online Java compiler. This online Java compiler in our platform allows users to write, compile, and execute Java code directly within the platform. So this feature gives users the first-hand opportunity to code by themselves, to apply the theoretical knowledge that they have in their head into the real-world scenario by themselves through the Java online compiler. Next up, we have the saved compiler code history. This feature enables users to save their compiled code history and allows them to track the evolution of their code over time. Furthermore, through this feature, we can save the compilation history in our database. We can get the compilation history from the database, as well as we can update and clear the compilation history. Also, through this platform, we can generate reports about the compilation history, so that the users could get a better understanding about their previously compiled codes and their coding standards that they followed, and the mistakes that they did, and they can get a good idea about their progress over time using this feature. Next up, we have the AI-driven error feedback tool. This is the unique feature that we have in our platform. So this through this feature, we can generate this feature generates an AI-generated user-friendly feedback after debugging a code. Through this feature, we can get instant error feedback, user-friendly interface. It contains user-friendly interface, and it has real-time analysis, and it has precise code explanations for mistakes. So this feature provides clear, simple explanations into the code snippets that we provide. And this is a unique feature in our code, since it provides simple explanations into a code, and it can be used to improve the coding standards of users that use our platform. Next up, we have the Java Theory Learning Point. Through this feature, our CodeRookie platform facilitates the acquisition of fundamental Java theoretical knowledge and concepts which are accessible through examples. Here, users will get the opportunity to learn about theoretical concepts through these resources, and they will get the facility to try those concepts into codes right then and there on the page itself. It allows, and also for system admins, they can add new theories to the system, and students can view the theoretical resources that are available in coding in our platform as well. And system admins can also update, delete the content that are in our platform, as well as reports can be generated. In these reports, the theory as well as the coding snippets that we tried, each individual student tried would be included in the report, so that the student would be able to get a better understanding about the theoretical concepts and the examples that they tried, so that since they tried those examples by themselves, they will get a better understanding rather than just looking at a set of examples on a web page. Moving on. Community support. This is also a key feature that we have in a platform. It's a collaborative forum-like platform that enables learners to interact, seek help, and to share knowledge. This is crucial, since this gives an solution to the solitude that is experienced by most novice programmers when they use platforms to learn about coding. So through this community support forum, if they face an issue when coding, they can simply just open a thread. They can post the problem, and their peers could answer those problems. So moving on, yeah, and finally, creating CodeRookie was just not enough for us. We needed to see for firsthand by ourselves how our platform performed in the real world in the hands of noise programmers. So what we did was that we gave access of our platform to a batch of 60 students. Out of those 60 students, 30 of them were advanced level students, and the other 30 of them were undergraduate students. So that we gave this access of our system for them for around a month, and after that we gave them a survey, and they filled it out. The result is on the screen as well. So through the survey, it is evident that almost the majority,
Excuse me,
about
sir?
90%. Sorry.
My apologies to disturb you, but I'd like to remind you of the time limit.
Okay, sure. So around 90% of them found out that CodeRookie improved their skill set as programmers, and most importantly, it improved the confidence in them when they come across errors, coding errors. They had confidence to, without panicking, to understand the errors to a great extent and to find solutions to them. So this is our team, and this brings us to the end of our presentation. Thank you.
Yes, nicely presented. Thank you so much. Ma'am, can we have the next presenter?
Sure, ma'am. We'll be proceeding with our next presenter. I'd like to invite our next presenter, Hong Fu, with the paper titled Early Stop Technique for BCS Decoding Algorithm under Tolerant Fault Probability. You may start with the presentation, sir.
Okay, can you hear me?
Yeah, you're audible.
I'm going to share my slide.
Sure, please go ahead.
Yep, I think you can see it. So,
It is visible.
yeah, thank you. It's my pleasure to share this this topic and this work. There is an early stop technique for BCH decoding algorithm on the tolerant fault probability. I'm a postdoc in SNT, University of Luxembourg. So these are my agenda. First, I'm going to talk about what is BCH code. It's kind of a for error correcting code or for error correction. And we are going to talk about the major application of this for error correction code, and we based on our necessary in the industrial and application, we would like to investigate the early stop approach for this BCH for this kind of error correction code. And the second point, we are going to provide a heuristic from our approach. This heuristic can help us to analyze mathematically approach to our fault tolerance probability for our proposed early stop approach. So based on this heuristic, we also can provide some theoretically analysis on our faulty probability of our proposed algorithm and early stop condition. So in the last conclusion, we are going to present this as a twin-win successful research case to show our proposed approach has been successfully engaged in a commercial product. So first of all, the BCH code is kind of a for error correction code using a linear algebra construction to help the digital communication to recover the error from the channel. So it has been widely used in the satellite communication, such as DVB-S2 standard. And flash controller, we are also using this kind of code, and this is also a broader code, well known as a Reed-Solomon code, which the difference is between the binary linear construction and the non-binary linear construction. So we can see that in the MATLAB math work, we cite the copyright from this standard. We can see that we usually use this BCH code as a outer code, and to enhance the error correction capability, we have inner code of error and more powerful LDPC code, which is also well known as a soft coding for error correction code. So I present as a feasibility of the implementation of the BCH code decoder in my GitHub. And one of the most important application for the BCH code decoding is the quantum post-quantum cryptography. We rename this a kind of approach as a MAC-Elise encryption system, which has been which will be which will be represent as a promising candidate of the post-quantum cryptography in the next 5 years. So first, we can see that the BCH decoding algorithm is based on 5 steps. First, we're going to calculate the syndrome from the receive cohort, and after we calculate from this syndrome, and we can, based on this syndrome, we can using some algorithm to calculate the error location polynomial, and this error location polynomial is important information for us to determine the error location deteriorate from the channel, and based on the Berry-Massey algorithm we're going to use is we can calculate the error value and the error location from this error locator polynomial. And the last step is that we can able to find where the error is, and we can know how much the error value is, so we can correct the error. So based on the literature, we can find the most state-of-the-art early stop approach from this early stop Berry-Massey algorithm. We can find these 2 proven lemma of the early stop designed for the Berry-Massey algorithm. So based on the inspiration of these 2 proven lemma, we try to extend from our following heuristic, which is based on the discrepancy, observing the discrepancy of during the Berry-Massey algorithm. And also, from another point of view, is to see how many steps we are going to observe during the Berry-Massey algorithm. So due to the nature of the Berry-Massey algorithm, they suggest we always doing the constant iteration, constant latency of the decoding algorithm is 2 times the error correction capability. So until we finish this 2t iteration, 2 times t means the error correction capability. Until we do this 2t iterations, we can get our result and solve the error from the channel. So we provide, based on the state-of-the-art early stop criterion, we bring up these 2 interesting heuristic for us to study and analyze our early stop decoding algorithm and provide a feasibility to theoretically analysis of the error on detection probability, to analyze the on detection probability, which means the faulty error rate of our early stop approach. So we can see, based on the first heuristic, if we have the BCH code delta, and we consider the delta a smaller subset of BCH code, and delta over V plus kappa. So we can see that if we have this code subset based on this heuristic A1, and we can make another heuristic 2, we can see if we assume we know the exact number of error bit caused by the channel is the variable E. We can see that this variable E will determine the effective iteration we really need to perform during the Berry-Massey algorithm. So we are going to based on our proposed early stop approach, we're going to estimate this E. If we cannot successfully estimate this exact number of error bit, we will cause some malfunction of the decoding algorithm. So there exists some probability we need to calculate how much we will have happen this kind of situation and or occurrence about the malfunction. So we propose this early stop version to observe the discrepancy of the Berry-Maxey algorithm based on the consecutive number of zero of the discrepancy. So based on, for example, we are going to observe 4 consecutive zero during the Berry-Maxey algorithm iteration, or up to 6 consecutive zero discrepancy for this early stop version.
Excuse me.
Yep.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, thank you. I will be finished in 2 minutes. Yeah, and the numerical analysis we have performed based on our heuristic, we can see that our proposed approach is around 10 to minus 120, which is quite low for our commercial product to have no any problem. We cannot, which means that we will not happen any kind of fault occurrence during our lifetime, and then we can see a more analysis of complexity. We can save up to 90% compared to the state-of-art early stop approach. So this is our product. We have provide a twin win successful to gain from the academic and improve and move forward to the commercial product. And this is our demonstration of the twin win successful story who inspire us to keep working on our research. Thank you. This is my presentation for this work. Thank you very much.
Thank you, sir. Ma'am, Monica, would you like to ask any question?
Yes, no questions from my end. We can proceed with the next presentation.
Okay. We'll be proceeding with our next presentation. I'd like to invite our next presenter. Our next paper presenter is Putana Chris with the paper titled Smart Living. So you may start with the presentation.
Yes.
Ma'am, the audio isn't connected, it seems.
Is my screen is
Your
show.
screen is visible, but the audio wasn't connected for the video that you played. Maybe you can try screen sharing once again with the option of connecting the audio as well.
Yeah, okay.
Okay.
Is my video is on your screen?
Your screen is visible, but the video isn't on yet. Yeah, it is on, but the audio isn't there. Ma'am, there's no audio in your screen sharing, so we can't really hear the video.
Only here the video didn't show the screen.
Your screen is visible and the video is playing, but the audio isn't there. There's no voice.
Yes.
Could you please share your PPT if it's possible and present it? You can share your video with us via mail and we can present it for you. Because there seems to be a problem with the audio.
I think it not have problem, but why cannot?
It could be possible that the screen sharing, you haven't shared the audio with the screen sharing. There's an option. You can share the PPT with us and then we can present it on behalf of you, the video.
Oh, yes. Okay.
So by the time we share your video, we'll take up our next presenter. You
Okay.
can share your video through the chat box. We'll
Okay.
share our mail with you.
Okay.
Yeah. Ma'am Monica, we have one presenter from the previous session. He can present while we wait for the video.
Okay, ma'am.
Yeah. So Ekvig, sir, you may start with the presentation if you're ready.
Okay,
Yeah.
I'm ready. Can you hear me?
Yeah, you're audible. Please go ahead.
Okay, good morning, everyone. My name is Chimdike from Nigeria. And on behalf of my topic, modeling of a pandemic compliant smart classroom door for the Nigerian education system. Before I start, I would want to state, I'll note that this door system can actually be applied to any other nation's education system and not necessarily that of Nigeria. And any other sector, parastatal industry, can equally adopt it and modify it by adding more sensors and programming to accommodate their peculiarities while they maintain the basic pandemic compliant nature of the system. By way of introduction, we all witnessed the COVID-19 breakout in 2019 and early 2020, the pandemic overwhelmed the whole world and basically caused every sector of the world to shut down. The organization marched out some guidelines which helped to leave criteria as included, but not limited to avoiding physical contact with surfaces while maintaining social and physical distancing, wearing of nose masks anytime you're leaving to a public space, and with a routine and compulsory temperature check at the entrance of every facility. Now, these guidelines proved effective, and as such, my team decided to find a way of integrating these guidelines into an automated and a smart system, which takes us to the concept of the doors. Yeah, we know that the door is an ingress to any enclosed premises. That means it is actually the first point of call. So there was no better place to integrate those guidelines than in the door system. The statement of the problem. I actually highlighted two major problems which this system will be solving. The first is the health risk experienced during the COVID-19 pandemic and the distortion in the school academic calendar. Even after the COVID-19 lockdown was lifted, the duties of testing temperature check was handled by some security men, which equally exposed them to contacting the pandemic. So we felt that there's a need to automate the systems and remove any human contact with potential patients. And also in Nigeria, it is disheartening that most of the institutions still have not fully recovered from the distortion in their school academic calendar, not necessarily because of the COVID alone, because of some other internal and political problems. And the second problem that this system will be solving is what I call the non-availability of an integrated and automated online attendance list. There are so many automated online attendance lists. We all know that attendance list is very important to the education system, but this attendance is different. Yeah, because this smart classroom door is actually a subset of a bigger project, which is the smart classroom itself. In the smart classroom, the system is designed to run in two modes. That means the people who are for the physical classroom session will be running simultaneously with those online. This makes provision for anybody who is not able to attend the physical classroom as a result of infection or quarantine or isolation can equally log in remotely from his or her location to access the classroom and not miss out on anything. So this door, what it does, it keeps log of people who have come to the physical classroom, while the web application actually keeps log of those who have logged in remotely and into a central pool from where the integrated attendance can be drawn. So the objectives of this study is to develop a smart classroom door that can help schools operate in a pandemic situation and to develop an integrated and automated classroom attendance system. Analysis of the grid works. We analyzed some works, and in the works we analyzed, most of them were centered on how to eliminate the basic or conventional, traditional manual door locking system, whereby they introduce RFID technology, card readers, remote control, and all whatnot. Also, some of the works equally, which were undocumented, made use of some biometric recognitions. But in all those designs, none of them actually applied the face mask detection into the facial recognition for granting access. And we actually made sure that this work was COVID-19 compliant because it ensured that people must put on their face mask before they are given access into the classroom, and the temperature must be within the specified range as detailed by the World Health Organization while lifting the COVID-19 pandemic lockdown. Now, the new classroom door design. In modeling this new classroom door, the system will be automated, and a record with mapped images of all the students and teachers who are to make use of the door will be created and uploaded to the system. The system will in turn upload data of its activities to a separate database from which the data can be fetched to create a class attendance list. I noted below here that this door system will have to interface with a smart classroom web application to maximize its functions, which we will come back to very soon. Now, the implementation materials include a high-performance computer board, a microcontroller camera, an open source operating system of which we use Linux, Python programming language, which gave us access to many libraries and pretest data. We use the Firebase, which is the Google real-time database. We use the non-contact infrared temperature sensor to sense the temperature of students or teachers who are coming close. We equally use the ultrasonic sensor to detect motion and when someone approaches the door. We use the 3mm LEDs to interpret signals, such as when the classroom is on, the different signal blink pattern will show. When access is granted, it will show, interpret differently, and so on. Now, down here, we'll see a block diagram of how the classroom door actually works, the mechanism. Now, a person approaches the door, the proximity sensor, which is the ultrasonic sensor, senses the person's presence and initiates the camera. Now, the camera scans for the face. When the face is not recognized, access is denied. And when the face of the student is recognized as a student who has already been programmed or captured in the system, it asks the camera to check for nose mask. The algorithm checks for nose mask. When the nose mask is not being worn correctly, access is denied. And when it is worn correctly, it initiates the thermometer to test or check the temperature of the person. If the temperature of the person is equally high above the speculated limit, access is denied. And when the temperature is within range or normal, as it will be, access is then granted to the person into the physical classroom. And once this is done, an update will be done to the real-time database attendance list. You can equally see this where you have students who have logged in remotely and their the log is actually updated to the real-time attendance. Now, going down here, I just wanted to point out something, which is to show that at this point where you have the cloud decision, this is because there could be reasons of network downtime. If the attendance of the person cannot be uploaded in real time, it would be saved to a local host, actually. That is the essence of this. Now, this is a board settings and sensor integration where you have the ultrasonic sensor. This is the temperature reader. This is the Arduino Nano board, which we use to integrate the sensors, and these are the LEDs which was used. And in this picture, we can see the door model where we use this small equipment because we could not afford to implement it in a real contactless door system. We had to improvise to make this work. So this is what the hardware looks like when modeled, where you have the sensors integrated and then plugged into the computer HP or i5, which processed the system. Now going down, we have the snapshot of what the attendance list looked like when extracted from Firebase real-time database. And then, because I mentioned that the system, the door system must have to be connected to a classroom web application to function very well. These are some of the core functions, control mechanisms that the door would initiate when incorporated into a smart classroom system. Only during their lecture period, as per the appropriate class schedule, can students enter the classroom door. This means that the classroom will be updated with the schedule of the school system and the classes, so that anytime it's time for the class, the system comes active. And once it is not time for the class, as in their schedule or timetable, no student can access the class, only but the teacher. Now, the teacher can equally grant any student access personally. The second, the device in the classroom that are essential for the class should turn on automatically when a user, such as teacher or student, passes the door. The door is designed in such a way that because it is part of a project where the classroom is made smart, so once the first person enters the class at the right class schedule, it triggers some control mechanisms. The light comes on and makes the place bright. If the temperature in the place is low, it triggers the AC, the cooling systems, and make them come on. And it keeps record of.
Yes, sir. You are advised to kindly conclude your presentation.
Okay. Results have basically concluded. So, successful implementation of a pandemic compliant smart classroom door. The system produced an automated class attendance list. So in conclusion, the results showed that the model provided an ideal classroom door that can run in the event of a pandemic situation. Yeah, thank you very much. Can you hear me?
Thank you, sir. Ma'am Monica, would you like to ask any question?
No, ma'am. Can we take the last presentation?
Yeah. I'll just have to share the screen for a second to share the video. Okay, we'll see if the video works or not. Please let me know if it's audible.
Hello everyone, today I'm excited to present our research on the paper topic Smart Living. I'm the representative for the presentation. My name is Anawat Yagla and I will be walking you through our findings. Let's go. The growth of industry has been interesting from steam power factory in Industry 1 to the digital era of Industry 3. But we are now in Industry 4 where cutting-edge technologies such as artificial intelligence, big data, and the Internet of Things are transforming how we live and work. The merging of 4G and 5G networks has created new prospects for improved connectivity and applications. In example, IoT allows devices to connect and exchange data, resulting in increased efficiency and production. Today, we'll look at how these breakthroughs are transforming our home and lifestyle. Before we begin our venture, let me evaluate some of the existing studies in this topic. Studies have carefully investigated the connection of smart devices with central standards such as Google and Siri, paving the path for seamless integration and comfortable in smart homes. In addition, there has been a lot of interest in the use of IoT in agriculture, often known as smart farming. Researchers have shown how real-time monitoring and optimization may improve agriculture output and sustainability by combining IoT, big data, analytics, and advanced farming practice. Now, let's talk about the design of our smart living system for the office. Our objective was to design a system that was both easy to use and adaptive to changing technology. To do this, we implemented incremental control feature and structured the system to support a wide range of brand and functionality. Automation is critical to our system because it allows devices to run effortlessly in the background based on quantifiable physical data. In addition, we implemented IoT functions targeted at improved air quality, resulting in a healthier living environment for residents. Moving on to the findings, we are glad to report that each system, lighting, ventilation fan, and curtain perform as specified in table. Furthermore, feedback from regular room occupants reveals great satisfaction with the new system as compared to conventional one. Users particularly value the additional control and automation functions, as well as the better air quality given by our IoT capabilities. These findings support the usefulness of our smart living system in delivering a more pleasant and sustainable living environment. To summarize, our study has effectively established the feasibility and efficacy of integration IoT system for improved home automation. We demonstrated how sophisticated technology may be used to improve the convenience, efficiency, and sustainability of living environments. Moving forward, there is certainly opportunity for improvement and more research. We need to solve these constraints and look at new approaches to increase our system capabilities for future use. Nonetheless, we are thrilled about smart living technology potential to improve our daily lives. Before we end up, I would like to thank CU Vision X for their assistance in supplying hardware and software for our research, as well as Ignite Creativity Lab for promoting an environment of research creativity. This project could not have been completed without their help. Many thanks.
Would you like to ask any question to the presenter?
Yes.
No, ma'am.
Okay. This brings us to the conclusion of the session. I sincerely thank our authors for the excellent presentations and contribution this session, and all our participants for being a part of this international conference. I hope this session was informative enough We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICTCS 2024. I'd also like to thank our session chair, Ma'am Monica, for chairing this session. A token of appreciation to the chair on behalf of Team ICICT and Global Knowledge Research Foundation. Thank you for your evaluation.
Thank you so much, and thank you so much to all presenters for their illuminating presentations.
Sorry, there was a technical issue. Before we end, it is my kind request to everyone to please turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.